Have you ever caught yourself romanticizing the idea of total self-reliance? Like just going completely off the grid, relying on absolutely no one but yourself? It is a super popular fantasy. But today, we're going to challenge that idea head on. Welcome to this explainer where we're looking under the hood of global trade. We're going to see exactly why interdependence isn't just some modern convenience, it is literally the engine of human prosperity.
I mean, really ask yourself, is true self-sufficiency the ultimate economic goal? Imagine, just for a second, completely isolating your family from the rest of society. To survive, you'd need to grow every single ounce of your own food, spin and sew all your own clothes, and build your own home from scratch using materials you harvested yourself. Sounds exhausting, right? That stark contrast really highlights the incredible reality of our interdependent world. We rely on thousands of people we are never going to meet just to get through a single day. But why is that?
Well, here's the boot sequence for our explainer today. First, the interdependence simulation. Second, absolute versus comparative advantage. Third, calculating opportunity cost. Then, expanding consumption frontiers, the range of trade prices, and finally, globalizing the model.
Okay, let's jump right into section 1. The interdependence simulation, booting up the Frank and Ruby sandbox. Let's meet the only two people in our simulated economy. Frank is a potato farmer, and Ruby is a cattle rancher. Looking at their production numbers, you'll notice a pretty massive disparity. It takes Frank 15 minutes to grow an ounce of potatoes and a painful 60 minutes just to produce an ounce of meat. Poor Frank, right? But then look at Ruby. She is an absolute powerhouse. 10 minutes for potatoes, 20 for meat. She's statistically faster at producing absolutely everything. Which leads us to a highly counterintuitive question. If Ruby is faster and more efficient at producing both meat and potatoes, why on earth would she ever trade with Frank? Doesn't it make sense for her to just be self-sufficient and completely ignore him? Hold on to that thought, because the answer unlocks the very core of economic theory. Moving on to section 2, absolute versus comparative advantage, deciphering the code. To solve this puzzle, we need to understand two distinct economic rules. Let's start with absolute advantage. This is simply the ability to produce a good using fewer inputs than another producer. In our model, time is the only input. So because Ruby uses less time for both goods, she definitively holds the absolute advantage. Case closed, right?
Well, actually, scratch that. Not quite.
That brings us to section 3, calculating opportunity cost, the computational trade-offs. See, we have to shift our perspective away from raw physical time and instead look at trade-offs. This is one of the most vital principles of economics you'll ever learn. The opportunity cost of an item is what you give up to get that item. Since Frank and Ruby both work 8-hour days, every single hour spent producing potatoes is an hour completely sacrificed from producing meat, and vice versa. Let's run the actual numbers here. For Frank to grow 1 ounce of potatoes, it cost him just 1/4 of an ounce of meat. But for Ruby to grow that exact same ounce of potatoes, she has to sacrifice a whole 1/2 ounce of meat. Because she is so incredibly fast at ranching, her cost of stepping away from the cattle to farm potatoes is actually really high. So the crucial point is revealed right here. Comparative advantage. This is the ability to produce a good at a lower opportunity cost than another producer. Even though Ruby is faster overall, Frank actually has the comparative advantage in potatoes because he gives up less meat to grow them. His opportunity cost is just fundamentally lower. Let's view these two protocols side by side to really let it sink in. Absolute advantage is all about physical inputs. Comparative advantage is all about opportunity cost. And here's the fundamental rule of our simulation. While one person can definitely have an absolute advantage in everything, it is mathematically impossible for one person to hold a comparative advantage in both goods. Because opportunity costs are inverses of each other, if Ruby's cost for meat is low, her cost for potatoes simply must be relatively high. Now for section 4, expanding consumption frontiers, breaking the sandbox limits. So, what happens when Frank and Ruby follow this mathematical code and decide to specialize? The results are basically economic magic. By specializing, with Frank focusing more on potatoes and Ruby on meat, the total resources in the system expand. Total potato production jumps from 40 up to 44 ounces, total meat production rises from 16 to 18 ounces. By trading, they literally bake a larger economic pie. Specialization allows both Frank and Ruby to consume way more of both goods than would ever be possible if they just stayed self-sufficient. Section 5, the range of trade prices, finding the mutual sweet spot. Okay, so now that Frank and Ruby know they should trade, at what price? In our simulation, they settle on trading 3 ounces of potatoes for 1 ounce of meat. This is the perfect mutual sweet spot. Why? Well, Frank pays 3 ounces of potatoes for meat, which is cheaper than his own cost of 4. And Ruby receives 3 ounces of potatoes for her meat, which is better than the 2 she could grow herself in that same amount of time. They both get a bargain. The underlying law we're seeing here is that for both parties to gain, the price of trade must lie strictly between their 2 opportunity costs. If the price of meat goes above 4 ounces of potatoes, Frank just walks away. If it drops below 2, Ruby walks. The price has to sit right in that middle zone, otherwise the trade simulation collapses, and someone loses out.
Let's scale this up in Section 6, Globalizing the Model, from sandbox to planetary network.
It's time to zoom out from our isolated 2-person sandbox. Just look at this incredible image of a bustling historical market. While we've been using a super digital, simulated lens today, this shows us that the fundamental code of comparative advantage is completely timeless. Long before anyone was calculating opportunity costs on a screen, these exact same invisible mathematical laws were driving human progress, pushing us to trade and connect in physical markets just like this one. And you know what? This scales up flawlessly to the nation-state level. Nations export the goods where they hold a comparative advantage, and they import the goods that other nations can produce at a lower opportunity cost. Just like Frank and Ruby, countries like France, Egypt, Brazil, and China are all vital interdependent partners in this vast global matrix. And that's what allows billions of people to enjoy a greater variety of things at a lower cost. Now, check out the sheer consensus of the data in this poll of expert economists regarding US-China trade. Despite how incredibly complex global politics can get, an overwhelming 100% of the surveyed economists agree that trade with China makes most Americans better off because it provides access to cheaper goods. It's quite literally the Frank and Ruby simulation playing out on a massive real-world scale. And that brings us right back to this foundational principle of economics. Trade can make everyone better off. It's a profoundly counterintuitive truth. Our instincts tell us that for someone to win, someone else has to lose, right? But the unseen engine of comparative advantage proves that when we specialize and connect, we actually expand the limits of what's possible for absolutely everyone. Which leaves us with a final thought to ponder. If interdependence is the fundamental mathematical code that actually drives global prosperity, how might we need to rethink our definition of independence today? Next time you eat a meal, wear a shirt, or use your phone, take a second to think about the incredible, invisible global sandbox that made it all possible. Thanks for running the simulation with me on this explainer, and keep questioning the models that run our world.